Hello everyone, this is our first video of video explanation of internal series. In this video, I will discuss how to build decision tree using ID3 algorithm. So the scenario is following table presents a training set D of class labeled tuples randomly selected from the all electronics customer database. The class label attribute bus computer has two distinct values, namely yes and no. Therefore, there are two distinct classes, that is m equal to 2. If class C1 correspond to yes and class C2 correspond to no, there are 9 tuples of class yes and 5 tuples of class no. Root node n can be created for the tuples in D. So we have to find first splitting criterion of these tuples using computation of information gain of each attribute. Second, we have to find the splitting criterion of these tuples using Gini index of each attribute, construct the decision tree. And third, construct the decision tree of both the cases, question 1 and question B and question 2, and compare the generated rules. So in this problem, we have given four data set attributes: age, income, student, credit rating, and class bias computer. Given this particular data set, we have to build decision tree using ID3 algorithm, and then we have to classify this new example into one of the class like yes or no. Now, if you want to build a decision tree using ID3 algorithm, the very first thing we need to do is we need to identify one of this particular attribute as the root node, and then we need to start building tree. But among these four attributes, which one should be selected as a root node? That is a big question over here. So that can be answered with the help of information gain. First, we need to calculate information gain for each attribute. What is information gain? Select the attribute with the highest information gain. Assume there are two classes P and N. Let the set of example S contain P elements of class P and N elements of class N. The amount of information needed to decide if an arbitrary example in S belongs to P or N is defined as information gain of P and N is minus P divided by P plus N proportion of positive example with log P divided by P plus N to the base 2 minus the negative proportionate of negative example log n by P plus N to the base 2 negative example. And the entropy characterizes the impurity of an arbitrary collection of examples, i.e. proportion of the data set made up of class I. Then the formula of entropy of all the sets is minus P log to Pi, where Pi is the probability of randomly picking an element of class I. Now, the one attribute which is having the highest information gain, that will become the root node in this case. So we'll start with the first attribute, which is age. We need to know how many yes and no examples in the particular case. So we have 9 yes and 5 no examples. So entropy of whole data set is equivalent to uh, minus 9 divided by 14 proportionate to positive example with log to the base 2 minus proportionate of negative example to the base 2 is equivalent to 0.94. Now we need to find the possible values for this particular age. The values of age are youth, middle and senior. Then the entropy of youth is where 2 yes and 3 no is 0.97, and entropy for middle aged where 4 yes and 0 no is 0, and uh, if there is 3 yes and 2 no in senior, then the entropy of this particular data set is 0.97. Now information gain, so we can calculate information gain by using entropy of whole dataset minus the entropy of a particular dataset. So the information gain for age attribute is 0.247. Now we will consider income as second attribute. Then the possible values are high, medium, and low. And in high there is two yes and two no. Then the entropy for high is 1, and in medium there is 4 yes and 2 no. Then the entropy of medium will be 0.9179, and in low there is 3 yes and 1 no. Then the entropy of low is 0.8112. Now information gain for income is 0.0293. Now we will consider student as attribute. The values for student is yes and no. Then S for yes, where 6 yes and 1 no. The entropy for yes is 0.5916. And for no, there is 3 yes and for no, then the entropy for no is 0.985751. Now information gain for student is 0.1516. Now, next attribute is credit rating. Then, in credit rating, there are two possible values, fair and excellent. So, if uh, in fair there is 6 yes and 2 no, then entropy for fair is 0.8112, and in excellent there is 3 yes and 1 no, then entropy for excellent is 1. Now, information gain for credit rating is 0.0479. We have we have the entropy for all attributes. Then, if we compare all the entropies, the attribute age has maximum information gain value. Now, second, find the construct decision tree splitting criterion of these tuples using Gini index of each attributes. We'll take class by computers. Then we can calculate Gini index by this formula. Gini of whole subset is equal to 1 minus summation of p j square. Here are 9 yes and 5 no for class boys attribute. Now, Gini for this whole data set is 0.4591. Gini index for age attribute, where youth has 2 yes and 3 no, then the Gini for youth is 0.48, and in middle aged there is 4 yes. So, and 0 no. So, Gini for middle aged is 0. And for senior, there is 3 yes and 2 no. So, Gini for senior is 0.48. Now, we will calculate weighted average by finding Gini index of particular attribute in dataset B. So, Gini index of whole dataset is 0.3428. Now, reduction in impurity of age, where age is V equivalent to Gini of whole dataset minus Gini of a particular attribute in dataset. So the impurity of age is 0.1163. Now Gini index for income. So in low value there are 3 yes and 1 no. Then the Gini for low is 0.375. In medium there are 4 yes and 2 no. Then Gini for medium is 0.44. And in income there are in high there are 2 yes and 2 no. Then Gini for high is 0.5. And weighted average for income is 0.3913, and reduction in impurity of income is 0.0678. Now we will calculate Gini index for student. In student uh, in student attribute, in yes value there are 6 yes and 1 no. Then Gini for yes is 0.244, and for no there are 3 yes and 4 no. Then Gini for no is 0.489. Then weightage average of a student is 0.3665, and reduction in impurity of a student is 0.0926. Now we will calculate Gini index for credit rating. So in credit rating, in fair value there are 6 yes and 2 no. Then Guinea for fair is 0.375, and in excellent there are 3 yes and 3 no. Then Guinea for excellent is 0.5, and weightage average of credit rating is 0.4285, and reduction in impurity in credit rating is 0.0306. So the maximum reduction in impurity is for the attribute age. So age is the splitting criterion. Also, age is the root node for decision tree. Now, decision tree for Gini index, where age is the root node, and we have now new table for particular data sets. Then we will find Guinea for this data set. So Guinea for this small data set, new data set is 0.48. Now Guinea index for income. So in income in high there are 2 no. So Guinea for no is 0, and for medium there are 1 yes and 1 no. So Guinea for medium is 0.5, and for low there are only 1 yes and no. So Guinea for low is 0, and weightage average of income is 0.2, and reduction in impurity in income is 0.28. Now Guinea index for student. So in student, in yes there are 2 yes. So Guinea for yes is 0, and Guinea for no is also 0, and weightage average of student is also 0, and reduction in impurity of student is 0.48. Now Guinea index for credit rating. So in fair there are 1 yes and 2 no. Then Guinea for fair is 0.44, and in excellent there are 1 yes and 1 no. So Guinea for excellent is 0.5. Weightage average of credit rating is 0.464, and reduction in impurity of credit rating is 0.016. Here reduction in impurity is maximum for the attribute student. So we choose student as a node. Now for table number 2, Guinea is 0.48. Now Guinea for income again is in medium there are 2 yes and 1 no, so 0.44, and for low there are 1 yes and 1 no. So Guinea for low is 0.5, and weightage average of income is 0.464, and reduction in impurity in income is 0.016. Now Guinea for credit rating, in fair there are 3 yes, so Guinea for fair is 0, and excellent Guinea for excellent is also 0, and weighted average for credit rating is 0, and reduction in impurity of credit rating is 0.48. So the maximum reduction of impurity is of credit rating, hence it is selected as a root node. And decision tree for question 1 and question 2 is um, here age is the root node, and student and credit rating are sub nodes of age. Thank you.